Hello everyone, welcome, and let us see how we can solve a second order nonlinear differential equation. So this equation has two parts, what is called the complementary part and the particular part. So our solution will be y is equal to y complementary plus y particular. So we start working and we begin by y complementary, which can be reduced of the form d squared plus d minus 2. There is a y here. Everything here is multiplied by y, which is equal to 0. Now, we note that d squared is the same as d squared over dx squared, and the d is the same as d over dx. So to solve the complementary part, we let our solution to be of the form y is equal to exponential mx. We differentiate y once to get y exponential mx. We differentiate y twice to get y double prime, which is equal to m squared exponential mx. Then we substitute our values of y in this ODE to obtain m squared plus m minus 2 exponential mx, which is equal to 0, and we note that exponential mx cannot be equal to 0, which means that m squared plus m minus 2 is the one which is equal to 0. So this is a quadratic equation which can be factorized as m. We can factorize it as m minus 1, m plus 2. Because when you have negative 1 times 2, it will give you negative 2. And you will have 2m minus m, which will give you this part. So, which is equal to 0, meaning that our m1 is equal to 1 and our m2 is equal to negative 2. So we write our solution of our complementary part. Yc is equal to c1 exponential x plus c2 exponential negative 2x. Then now we come to working on the y particular, whereby now we are going to, our y particular is equal to of this d squared plus d minus 2 y is equal to exponential 2x cos of x. Our yp will be equal to exponential 2x cos of x divided by f of d, which is equal to exponential 2x cos of x over f of d plus a, which is equal to exponential 2x cos of x divided by d plus 2, you square that, plus d plus 2, that one, minus 2. So that is how that one will become, applying this principle there. So yp is equal to exponential 2x cos of x divided by, we expand this part so that it gives us d squared plus 4d plus 4 plus d plus 2 minus 2, which is equal to exponential 2x cos of x divided by, so after factorizing this here will give us d squared plus 4d plus 4. So you have d squared, you have 4d plus d, which will give you plus 5d. Then you have 4 plus 2 will give you 6, minus 2 will give you plus 4. So the next step, we note that y particular is equal to exponential 2x cos of x divided by minus 1 squared. We are substituting the coefficient of x here, which is 1, plus 5d plus 4, which is equal to exponential 2x cos of x divided by 5d plus 3, because this is minus 1 and plus 4, which is equal to exponential x, 2x into bracket 5d minus 3 divided by 5d minus 3 multiplied by 5d plus 3, everything cos of x. So here what we do, we multiply by 5d minus 3, and we divide by the same so that we don't affect our working. So yp is equal to exponential 2x into bracket. D means we differentiate. When you differentiate cos of x, it will give you minus sine of x. So you will have minus 5 sine of x minus 3 cos of x. We close the bracket, divide by 5 times 5 will give you 25. D squared minus this and this will give you 9, because it is a difference of two squares. So exponential x into bracket minus 5 sine of x minus 3 cos of x divided by 25 into bracket minus 1 squared, close the bracket, 9. So yp is equal to minus exponential x into bracket 5 of sine of x plus 3 cos of x. I have factored negative outside so that these ones can become positive. Here you have 25 times negative 1, which will give you negative 25, plus negative 9, which will give you negative 34. This is the same as 1 over 34. This negative will become positive. Exponential x into bracket 5 sine of x plus 3 cos of x. So our ODE was d squared plus d minus 2 u y is equal to exponential 2x cos of x. So our solution is will be y is equal to y complementary plus y particular. Now since we have worked our y complementary and y particular, so we are going to combine the two and we write our result as follows here. So our y is equal to c1 exponential x plus c2 exponential negative 2x plus 1 over 34 exponential x into bracket 5 sine of x plus 3 cos of x. So that is our solution of this given ODE, whereby we have obtained the particular part by use of the inverse operator, and our Rx in this case was of the form exponential ax vx. That was our form. So whereby we have applied our yp as equal to exponential ax v over f of d plus a. That is the fact we have employed to obtain our y particular. Thanks so much for learning with me. On more such learning, tune on to my YouTube channel so that we may continue learning together. See you in the next presentation.